This presentation is part of a series regarding manufacturing. Today, we will discuss about digital transformation in manufacturing. My name is Jose Coronado, Director of Product Management at PTC, and I'm responsible for Creo Manufacturing Extensions. Just a very quick overview of the different workflows that we support with Creo. So we have the design to manufacture functionality here outlined. It can be additive or machining. For instance, we can have now generative design, geometries produced by artificial intelligence. Maybe you are aware of this kind of functionality in Creo. We can have our legacy parts that we have been producing in Creo for many, many years. And both can be completely manufacturable with Creo. So we can create directly machinable shapes with generative, can create either legacy-based geometries or bionic shapes that will go into the additive workflow. And all of them can be simulated and sent to the different machine tools, hybrid, or 3D printers themselves. So a word about the strategy on the two sides. I would say at this moment, oversimplifying, two sides of the story. For one side, additive, which is new, is something that many of you or users are either experimenting or already using for full production. For many years, almost, I don't know, maybe 35 years, you have been using additive for prototyping. This is not on discussion. We are talking here about functionality that you can use for end-use parts production. So our additive strategy having around lightweight design, and this is based on Creo users' feedback. Lightweight design is very important. We have been working on generative design in one side of the story, in lattice modeling in another side of the story to achieve lightweight design objectives. Also is another component, very important, is self-supporting geometries. So more and more the supports are either eliminated completely from the design, from that tray, or are created as a self-supporting geometry. As a byproduct, we are enabling biomimicry, and for sure, one of the objectives is enable the interoperability with basically any machine that we can see in the market. And all of this fully embedded into Creo. The other side of the coin, I will say, is our machining solutions. Here, I will just highlight that in the subtractive side is the objective and investment having in the multitask machines programming, very complex machines, 5-axis high-speed milling, continue with NC process automation technologies that are embedded in the machining applications of Creo NC, as we called it, and more to support the mixed workflows for additive and subtractive. So, and again, the idea is to support all of this inside Creo, fully embedded inside Creo. Now, this is just a general introduction to Creo manufacturing. Very, very basic, very highlight, no details, but just to show you that direction. Now, in the PTC ecosystem, we have strategic partners that complement our technology, solutions that are fully embedded inside Creo and work as regular Creo functionality that was produced by PTC. So one of these strategic partners is HCL Technologies, and today I have the pleasure to share this presentation with Robert Overfall, which will give us a demonstration on a DFM Pro. Robert is a senior solutions architect with over 30 years of aerospace and oil and gas engineering background, with a degree in technology management from the Bright Institute, and with HCL, 3.5 years with HCL so far. So, Robert, up to you to continue with the presentation about DFM Pro.
Hello, everyone. Thank you, Jose. I appreciate the good introduction for us at HCL. It's a pleasure for us to be here today, partnering with you over the years for our product that we have called DFM Pro, designed for manufacturing. I'm currently going to be showing a demonstration inside of Creo 8.0.3, and I'm running our newest application for DFM Pro version 9.4. And so we have about 280 specific manufacturing rules for DFM Pro that we'll be demonstrating here. I won't go through all of them, but I will go through several to show how DFM Pro works. And so what we'll do first of all is you'll notice here that DFM Pro is essentially an add-in inside of the application. So we're seamless inside of the Creo application. That Creo application itself has many different applications that are associated to it. But in this case here with DFM Pro, you can see that our menu system is attributes itself to specifically concerning the DFM Pro analysis aspect. And so what I'm going to do today is I'm going to start the DFM Pro application. And once I start that, you can see that we get our DFM Pro menu system here, property sheet, that comes up. And you'll notice a couple of things. First of all, this particular component that I'm going to be analyzing, we're going to look at the entire part, all the holes, slots, grooves, anything that's in this part with the analysis from DFM Pro. But you'll notice one thing, that this is an imported part. And so with an imported part, you'll ask, how does DFM Pro then run the analysis to look at manufacturability and specifically manufacturing features? And so what we end up doing with this application is we end up running our proprietary DFM Pro application using feature recognition. It's something we started out with many years ago, and now we license it, and it's very, very fortified for manufacturing components, as well as many other different types of processes, including assembly analysis. And so you'll notice a couple of things here. I've got materials defined. So I went in and defined this as 6061T6 material, which is an aluminum alloy. And you'll notice when I started the property sheet for DFM Pro in Creo, it pulled the data in automatically. So it read the information in here. And that's one thing that we do, is we keep in lockstep with the CAD systems in PTC. We are, right on top of all of the different aspects of geometries and functionality that they provide through their API that we have access to. And with that, we write all of our software using those APIs, and of course have our own APIs. And so now with DFM Pro here, you can see there are a couple of things that have taken place so far. We have a nice menu system up here. We have a way to look at the analysis data. We even have a costing module, and we have a server that will batch assemblies. And then on top of that, from the user input perspective, there's really nothing for me to select here at this point, because I know that I'm working in a milling perspective. So one thing we can take a look at, though, is these are what we call rule files, and the rule files are associated to the list of parameters that are used to run the analysis. So the analysis basically goes through and uses a selection of rules that here you'll see I sorted by the rules, and I have 55 rules selected out of 275. And so those cover a category of milling, turning, general, and drilling. And so with that, I'm able to go ahead and tell DFM Pro to use this specific file with this extension to run the analysis. And then what ends up taking place is feature recognition will run. It will analyze the solid model, put all of the feature information into an array, and then bounce each and every one of those features, for instance, all the holes, off rules that are related to hole analysis. And then based on that information, we get results. And so with that, it's not only prismatic milling and assembly, as I mentioned, and of course, we have other things too that we can analyze for additive manufacturing, casting, die casting, and so on. I'm going to be interested today in running the prismatic mill, which was my default setting, and I'm going to analyze the entire part that has these gray colors in it. And so with all of these gray colors, those are all machine surfaces. So there's a bunch of different machine surfaces that have taken place on this. And what we want to do is we don't want to analyze the casting per se. We like to analyze all of the features that are associated to the color selections. And so with that, I'm going to tell DFM Pro that I want to analyze using those colors. And so there is that capability here where I can go in and tell it to select a region. And when I select that region, DFM Pro will go through and then utilize that region for the specific color. Now, to save a little bit of time, because I know I'm limited on this presentation, I'm going to import the results that I had already run previously. And here's one nice thing about this capability. In certain cases, some processes may take longer than others to run the analysis. So what we allow you to do is once an analysis is done, you can save off the actual snapshot of the DFM Pro analysis. So let's take a look at the analysis here. And so we're going to go ahead and run this this machining, and we'll pull that in. You can see that's how fast DFM Pro is. And so some of the things that have happened here so far is when I ran that analysis, it ran the feature recognition and it ran the rule library against feature recognition and then came up with what we call recommendations. So here's the level of rules that are associated to DFM Pro. So no longer does a user have to go through and do section cuts on a part to figure out if he's got, you know, the configurations correct, the fidelity of the actual geometry from a modeling perspective in terms of manufacturability, right? And so we'll take a look at some of these manufacturing rules. One of the rules that we can talk about here is depoles. And so if I click on the depole rule here, you'll see that what DFM Pro is going to do, it's going to take the liberty of each instance and it's going to load that instance up for me and highlight it. And so it's zoomed up to it automatically. I didn't do it. And basically, it's going to give me the information about the specifics. So just so you know, I happen to know that for depoles, what's considered a depole is when the ratio of the diameter to depth exceeds 8. And that's our standard value inside of the system here. So if you do a division from the diameter into the depth, it better be less than or equal to 8. And if it's over 8, then what ends up happening, it becomes what we come to know as a depole. And so in this case, this one's pretty close. It's 8.03. So it's right on the cusp of being within tolerance, basically, for the maximum of the depth that you can cut. And because of the fact that I chose aluminum, that's probably going to be okay for this part. So as we go through, we'll start looking at some of the others. There's another one. There's a couple of them that have that same size. But as you'll see here, that diameter is going to change up in this value here. So now the ratio is 11.2 for this particular hole. So as I come through and look at that one, now that hole goes pretty deep. And so that basically violates the 8 custom rule that we have that basically says if I have a depth that is greater than the diameter, which is that value of 8 for that particular ratio, then let's go ahead and flag it. And that's what is happening here right now. We are actually flagging geometry so that you can see the geometry and what's taking place from a manufacturing and machining perspective. And so as we're going through and looking at the application, let's take a look at some of the others here. And we can look at some things that are going on from this perspective here that you see this little menu system popping up. Well, one of the things that happens from a design perspective is designers come through and as they're using the system, they may need to have a piece of geometry or an instance of geometry. It needs to remain the way it is, even though DFM Pro is making a recommendation. And those recommendations go deep. In fact, we have a help file that's available for those recommendations. This helps understand what the rule does. It explains it. It gives the recommendation. It shows the right way to machine and the wrong way to machine. And this is actually a good tool for new designers that come on board that don't really know manufacturing. So in this case here, what we're going to do is I'm going to zoom up on this particular item here, and we'll take a look at it from this perspective here. And as I'm zooming up on that, you'll see that the instance is available here, the whole is available. And so what I'm going to do is I'm going to create a note here, and we'll just put the word note, and we'll call it note 1. I can put anything I want in here, but what I'm going to do for this particular case is just tell it that I want to capture it. And you'll notice I put a little mark there. The nice thing about that now is I now have told DFM Pro that I want to use the toolbar here to take a snapshot, and I want that snapshot to become available inside of a DFX report in Excel. So if I press the button now for a report in Excel and I tell DFM Pro to go ahead and do that, let's say I'm a designer and I want to communicate with my manufacturing facility and I want to let them know that I need to have something the way that it is. So I may decide to fix all of these things, but I may need to leave that one there. So as DFM Pro is going through, it's gone ahead and it's generated the 2 files for me here. And so with that, I'm going to take a look at what DFM Pro is showing me from this perspective here. And we can take a look at the actual file. So you can see it took a snapshot of the file that I'm running. So the part has been activated and it takes that snapshot. And of course, I'm in Excel. It looks at the information about the version of Creo that I'm running, the version of DFM Pro, who I am as a user, what manufacturing process I chose, what percentage of data that I'm looking at here from a nominal width perspective, which we didn't include. So it shows the unit of measure we're running in millimeters and so on. And so taking a look at some of these things here, remember that in deep holes, we had a violation or a finding. And so with that finding, we wanted to capture some information. There's the note. And so you can see what DFM Pro does. It captures the information about the parameters and the ratio. And then, of course, at the top of this Excel spreadsheet here, I could put the required actions, the status, and so on, and I could send that off to my manufacturing facility to tell them that I would like to, for instance, leave this way, or I need to have it this way. And so they would have to figure things out. But generally what takes place in DFM Pro, because of these findings and the tribal knowledge captured in the rule file, it behooves the designer to make changes to accommodate the findings that DFM Pro is looking at. And so here, holes intersecting cavities, that's another one. And so we take a look at that rule, and you'll see there's 4 instances here. And so as we go through and look, and if we go down and look at, there's a bunch of different holes that are intersecting here. And so with that machining process is going to be very critical for manufacturing. So what we want to be able to do is maybe give a note to the manufacturers as well that we can tell them, hey, we have this case here, and even maybe from a quality perspective, we've had issues in the past. And so we want to make sure that we're looking at specific things and communicating correctly using the tool. And that's the beauty of DFM Pro. So here's some criticality items here. And one thing I want to mention about the criticality, and then we'll come back, is DFM Pro sorts by criticality. So critical items in aerospace and defense, generally, just for one instance of a mistake, will cost anywhere from $8,000 to $16,000 if it has to go back into an ECO and go back into engineering to get a change. That's for one instance. And so basically looking at some of the things that we've already seen in DFM Pro, we might have to send this part back to get it revamped from an engineering perspective. So as we go through here and look at these criticality factors, you'll notice that DFM Pro is also sorting those and compiling those into a list of criticality. So another thing that we can take a look at here is narrow regions and pockets. And so what DFM Pro is doing, it's showing us here that we've got this narrow region, and with that narrow region, it's telling us we've got one instance. And if we take a look at that instance and I zoom up here, it's telling us here that the recommended value for the narrow region should be greater than or equal to 3 millimeters. And in this case, we just barely hit the max. And so, but DFM Pro is base, or the minimum, I should say. But DFM Pro is basically telling us that you know, it looks at these little values here and it gives us the comparison, and that's all done through that feature recognition and the rule base. And so with that uniform non-uniform bottom radiuses here, we can take a look at some of those. And it's basically going through and looking at this case here where it's showing us that there's actually a step in the wall here. And so they're telling us that there's an issue with that. And so as we go around, you can see that DFM Pro is taking the liberty of zooming in on all of the different cases for us where we don't have to figure out or do section cuts or those types of things. Those are useful, and you can still subsidize the analysis with those tools that are provided in PTC. Which is a great tool, but however, you know, it's nice to be able to zoom up. By the way, DFM Pro does the same thing in assembly mode and removes all the esoteric components so you can get right to the issue and the instance that it's looking at here. Minimum diameter holes, let's see here, thickness check. Here's a good one. So you'll notice that thickness check here is basically looking at the entire model. And it's going through and looking at a comparison from feature to feature. And so in one case here, if we take a look at this and we look at the actual thickness here is 1.172 millimeters. And you'll notice that DFM Pro is showing us the case where it's actually taking that image and it's showing us where that image is in relationship to the other image. And so here, from this feature to this feature, there's a distance of 1.172 millimeters. So now, if this part happens to be under pressure, and which it would be, then there's going to be a problem here. And so you'll see as DFM Pro is going through and it's looking at that, the values are changing, but it's intelligent enough through the feature recognition and the logic that we've put together to be able to analyze those things. That might be really difficult for a designer to go ahead and check to see if he's under some certain value. And you know, the thing is that I find from a manufacturing perspective when I go into many different companies is that some companies say they have a design for manufacturing rule base, but that's generally paper, or it's tribal knowledge for each individual designer as they're using it. And then, of course, in manufacturing, there might be documents in a toolbox or something like that. And so, again, the nice thing about DFM Pro is if you think about it here, what I'm doing is it's one-stop shopping. I'm going right to the documentation. It's connected directly to DFM Pro, and everybody will be reading out of the same document when they go through and look at the information about the specific rules. And in this case, here's the thickness check rule that we were just looking at. And so, you know, going through on that, it's really easy to be able to come through and take a look at, let's just say, if I wanted to do a view here of just a couple of different items, I can highlight those and you can see what DFM Pro is doing now. It's taking and looking at some of the items that are selectable here from this tree. And so I can come in here and take a look at some of the items here and look at the dimensions. Then I can just simply go back into the view here, and then based on that view, I can see the ones that I was interested in and were highlighted. And let's take a look at what these values are here. And I'm hoping that they're going to be, no, they're still less than the 5.0 minimum. And so, and that value, by the way, the recommended thickness, let's take a look at that for a minute. So you're going to ask, how does that happen? So we'll take a look at thickness here. And so I already have it in the screen here, so we'll go ahead and do that. So recommended thickness check here. So you can see this is where the values are coming from. And so again, the help file, same exact button, same exact help file that's available in here is also available in the rule file. So those subject matter experts that go in and configure these values for concerning their tribal knowledge, they can capture that information. And when that information is captured, then they can go ahead and use it in the analysis process. And of course, you can also put some values in here, an alert setting when you're getting close to the value here. And so I don't have anything set up in that at this point in time. But going through and looking at it, so as you can see so far, what I've done with DFM Pro is I've used the muscle memory of the system, which goes and uses the exact same logic to go through. It runs the analysis, and then based on the features, and as those features have been found and going through and looking at those, I can go through and select those and tell DFM Pro that I want to, go ahead and create a note and send it to someone in an Excel spreadsheet, or I can go ahead and take and basically, let's go down to the bottom here and I'll show you something. We'll select all of these and then I'll tell it to ignore instance, right? And so when I do that, it's going to ask me, do I want to put a note? And I'll just say note here. And again, just to type something. And so what DFM Pro is going to do now, it's going to put those in an ignored instance list. And so that's how easy it is to do a justification on the system to be able to make it so that you can work with the system at ease and it's not overburdening the users as they're going through. The idea is that a designer will make the changes necessary, and some of these changes are going to be very costly if they're missed. So there we go. That's how DFM Pro works. And so with that, we have some, other rules that are available, basically giving us part size, width, so on, actual value, and ranges of the part size itself. Here's one that's going to be interesting, and I saved this one for last. So here we have a hole, and that hole has been put in, and it has a flat bottom. And so if you look at this and what's going on in this case here, that particular part, if we zoom up in that location, you'll see there's a flat bottom here. And we're not really sure what this tool is going to be doing when they thread this to actually put some type of maybe a fastener in from one component to another. But the fact that it's got a flat bottom in there is very interesting. So it's an obvious, kind of a design situation where that should probably have been a drill point angle, or it should have gone all the way through the hole, depending upon how that is, how that was set up. And so, as you can see, though, it's hard to get to that location because it's embedded inside, so you really can't get to it. But DFM Pro has taken the liberty of selecting that and showing us those things. So now with the tool here in Creo, you could go ahead and select this face and then tell it you want it to do a zoom on the section cut there and zoom up into that. But DFM Pro has already given us that information. One other thing we can show here really quickly, and this is a big one, believe it or not, is that we have users and individuals that tell us about specific things for specific parts where DFM Pro, what they're telling us is, you'll notice that it's finding some sharp corners on the outset of this thing here. So what ends up taking place with this is that would be, probably difficult to machine if you needed to call out a 0 size radius on this. And generally what ends up happening is you have cases where, sharp corners are called out, but the blueprint or the design, 2D design might actually state, unless otherwise specified, fillets and break edges and so on by specification. And so DFM Pro is able to go through and look at those. In fact, we don't show it, but we have a set of 2D rules as well. But we encourage all of our customers that are moving forward with Creo and DFM Pro to follow the trail of all the others that are trailblazing for MBD and, of course, digital transformation, because really that's what this is. This is the entry point and the most critical entry point into digital transformation, where we're analyzing geometry from a manufacturability perspective. And as I said before, imagine spending $8,000, even if there was 5 findings in here that were changed, that would be a big savings for a company to go through and utilize some of that technology. A couple of other things I'll show you here really quickly is we have a PLM integration. So the information that I showed when we output that file is part of the system where if you have PLM integration, you're pushing and getting files from your PLM system, DFM Pro automatically does an integration. I don't currently have that on my system, but if I did then, and I push this part back, any output files that I selected, if these were on, would travel back and forth by the revision of the specific part as it was pulled down from the PLM system, and then of course pushed back. And so that's the way that goes. You know, there's a lot of different things that you can do with DFM Pro from that perspective. So there's the reporting information that we had here. Of course, the costing module is a SQL database that we have that's connected to DFM Pro, and I'll just quickly show you some of those things. Now that we've looked at the analysis phase, DFM Pro also takes the liberty of utilizing the information from the feature perspective. It takes that information, it bounces that off a costing database, which has a series of information about specific volumes of material, by machining process, by tooling, and those types of things. And it comes up with a view of what the part would actually cost based on some prerequisites that are put in. And one was the material that we selected. And so here, if you look at, if I wanted to, I could actually send this now to the database, use it. Then if I went back as a designer, made some changes, and the changes actually took the cost down, then I would see that delta difference. This is not a should costing system. It's a quick indicator system, but I'll show you some really cool stuff about it. Is it highlights some of those things that are the really high cost values all the way down. So you can see the sliding scale here in this chart to go through and the machining processes of those. And then secondly, what we can take a look at, we want to look at the operation detail. This is really intriguing to folks when I show this, is we have a set of machines, and you'll notice these machines are picked as DFM Pro goes through and looks at the specific geometry. And so you'll see here it has pockets and slots and so on. And so these are the actual selections associated to the analysis based on their cost. And so as you're going through and you're looking at some of those things, you can see that DFM Pro is well aware of the geometry, the manufacturability of the geometry, and then also the cost of volume of material removal, again, to get that quick cost indicator. Companies are finding this very invaluable from that perspective because the designers need to know if they're making the design worse or more costly, or if they're making a design that's going to be more efficient to run the manufacturing processes, and then also to save the company money. And so, you know, right there in those two items here in this this view, we're able to pull in that information and give that information across the board. And so basically, you know, with DFM Pro, I showed you the rule manager. That's that file that we were looking at. And basically that rule file is chock full of rules that can be selected, that can be configured. It can, those configurations can be modified by users. We call them subject matter experts. DFM Pro is very extensible, meaning we can create an environment for an entire organization of designers strewn all over the place and have them access the same information. And that information could be, you know, the rule files that we're configuring. By the way, those have an extension. They're just a file that can be configured. We have a backend database that's associated to that those rule files, and with that backend database, you're able to do some other things with it as well. And so it's interesting with DFM Pro, like for instance, here I have an assembly, and really quickly I can go through and tell DFM Pro I want to run the analysis on the assembly. And so I'll import that as well. And so let's see, did I run the analysis on this? Let's just run it. Let's just run it from scratch. So you can see here I have an assembly. And while we're going through this really quickly, same user interface, only now I'm going to be talking about running an analysis using an assembly. And so based on that, I can go through and look at my assembly rule files here. And as I'm going through those rule files, looking at, excuse me, the application itself and running through, I can go in and look at my documents, and I can go to my demo folder. I can go pull in Creo demos, and then I have a set of rule files that are available in here that I can select. And as I mentioned, those rule files are basically available to me so that I can use many different types. So if there's different configurations, different shops use different materials or only focus on specific materials, then you can be very specific with that. So I'm going to go ahead and load that up, and you'll notice that the assembly mode has been selected. And so with that, I'm just going to go ahead and run this analysis. And the reason why I want to do that, excuse me, is that I want it to go through and I want you to see what's going to happen here. So basically, we're looking at all of the specific items. So there's all of the components that are inside of this specific assembly. There are also features that are associated to it. So what DFM Pro has done already using the feature recognition application, this is live, folks. It's running this analysis on this assembly, and when it gets done, it's going to give me the findings of that. And so we're at 95% now. So a set of rules that are available inside of that rule manager file that we had, that I selected, basically is going to come up and it's going to show me some things. And now you'll notice that it's got the entire part selected. So here it's telling me that I've got a situation where I've got a whole alignment case. And so what I want to do is I really want to get DFM Pro. I want it to actually remove all of those esoteric components, as I mentioned. So with that, I would like to be able to show you how that works here really quickly. So I'll just go ahead and apply this. And as I go through and look at another rule, and then I come back into that whole alignment, you'll see what it's done. Now it's removed all of the other components. Now I'm able to zoom up on that. And again, with this, now I want to be able to communicate. So let's say I'm somebody that is in assembly and, going through and doing a design check. I can go ahead and tell them, hey, you've got a misaligned hole here, and that baby is probably not going to line up because of the threads and those types of things, and it's going to make it difficult to assemble, if probably impossible. And so DFM Pro is able to go through and look at the most minute cases where we have the value here of the recommended value is less than or equal to 1 millimeter, and here we're at 5 millimeter for a misalignment. Let's see, interference detection. DFM Pro is going to highlight all of the different cases for all of the different components that are associated to the particular parts and the interference that are with those as well. So with that, I thought I would show you just some of the capabilities of DFM Pro with the assembly as well. And then here's a cool one here, bolt and screw rationalization. So let's say I had a set of fasteners, and those fasteners here, I have 4 that are exactly the same, and then I have one that's an outlier. And I'm going to prove that because DFM Pro is going to show me that. So what I want to do is I want to select that, and you'll see what it's telling me here. And we'll associate that here for a second so that we can make that wider. We can always put it back. So there's 4 that are the same and 1 outlier here. And so that particular outlier is one that could have been the same. And so we've gone into shops where they have thousands of fasteners. And so we created a rule called bolt and screw rationalization. Will allow you to and help you through an assembly rationalize those. So you say, okay, where do those go? And that's the reason why I had that assembly thing turned on here. So if I say apply and OK, and I come back in, we'll just come back into that and take a look at those again. And that's where those bolts go. And so that's basically how DFM Pro does it for us from an assembly perspective, just a few things. So I didn't select everything to show because I know we're limited on time. And so what I would like to do now is turn it back to Jose, and Jose can take over and he can conclude. Thank you very much.
Thank you, Robert. It was a very interesting presentation on how HCl technology, DFM Pro, can help in that digitalization of the manufacturing processes for Creo users. So excellent examples in the machining area. Thank you so much for being in this presentation with me.
Oh, thank you. I greatly appreciate your time. Thanks for letting us show it.